So let me introduce you to this idea of Dalton's atomic theory. It's kind of the basic theory that all of these other theories are based off of. We sometimes refer to it as the billiard ball model of an atom. And the idea that he said was that every element is made up of tiny particles called atoms. We've kind of already discussed this as one of our basic assumptions in chemistry. The atoms of a given element are identical. So if I find a bunch of atoms and they were all the same element, oxygen, I would expect all of those atoms are identical if I'm talking about Dalton's atomic theory. Spoiler alert, later we're going to say that that's not true, but chemicals, and if it was a different element, they're going to be different in some fundamental ways. So in other words, all the oxygen atoms are identical to each other, but they're all different from all the hydrogen atoms. Chemical compounds are formed when we bond two elements, atoms of two elements together in different ratios. So I can make different compounds from the same two elements by combining the atoms in different ratios. So in one case, if I had a ratio of 3 reds to 2 greens, whatever those elements are, that would make up a compound. And when I find those compounds, they will always have that same fundamental ratio of green to red. But I might find another compound that has 2 reds and 1 green. And then the last thing was that what is a chemical reaction? A chemical reaction is when you're reorganizing these atoms. So you are changing the way that they're bound together. So you're breaking them apart and forming new compounds with different ratios. And the atoms themselves are not changed in a chemical reaction. We're simply kind of breaking them up and making new patterns and new combinations. So if we look at some of these pictures, we say that, again, these Dalton's atoms were just like billiard balls. That's why we call it the billiard model. And so we see that all the reds are the same, all the blues are the same. In this case, red is representing oxygen and blue is representing hydrogen. And looking at these, we're representing them by different colors, but they're also different sizes, and we would expect different masses. However, all the hydrogens are the same, all the oxygens are the same, but hydrogen and oxygen are different. Similarly, we say that we can combine them in specific ratios to form compounds, and 2 elements of Dalton's atoms can combine in different ratios to make different compounds. So over here, I have a compound with 2 hydrogens per 1 oxygen. You might recognize it as water, H2O. Over here, I have 2 hydrogens with 2 oxygens. So this is fundamental. Now this is a 1-to-1 ratio, really, because 2 over 2 is 1 over 1. So this is a 1-to-1 ratio of hydrogen and oxygen. This is a 2-to-1 ratio of hydrogen and oxygen. So both of these compounds involve hydrogen and oxygen being bound together, but they're in different ratios. So that's what we're saying with Dalton's theory.